Hello, my name is Daniel Caro. I am a researcher at Louisiana State University. I have been working on my PhD with Algae and Cyanobacteria with the aim of producing chemicals and biofuels. And today I am going to show you a little bit of how to work with algae and cyanobacteria to obtain these chemicals that you normally would take from oil. Okay, so the way we start, where everything starts, is in the incubator. So come in here. The incubator is basically a place where we grow the algae and the cyanobacteria. As you can see here, we have this beautiful green liquid with algae, and this is what we are going to use to obtain the chemicals that we are interested in. One interesting thing or interesting factor or aspect of this is that we don't have to provide sugar for these to grow, because what they are doing is that they are using the light, the fluorescent lamp, the light coming from the fluorescent lamp and the carbon dioxide from the air to produce their own sugar. And that sugar is the one that they are using to produce the colors that you see and the other chemicals that they have inside. So we need to be able to grow the algae until a certain point, until a certain concentration of the biomass, so we are able to extract what we are aiming to extract. As you can see here, the intensity of the green color is different, and that is based on the concentration of the algae in the liquid. So these are younger cells, and then you have to keep growing them until they develop this dark green coloration. This is an indicator of how many cells we have, and of course how much chemical we can extract from them. So the way you measure the concentration is by measuring the optical density or the absorbance at a wavelength of 730 nanometers. And that is what is going to tell you how many cells and how much biomass you have in the liquid. And the way you do that is like you pour some of this liquid to a cuvette, and then you are able to measure the absorbance or the optical density using the UV-Vis spectrophotometer. Okay, so after we are able to grow the algae until the concentration that we need to lyse the cells open, because we need to get the materials that are inside of the cell. So the way you do that, you can either do it chemically or mechanically. Today we are going to do it mechanically. So what you do is that you take some of your liquid and then you use a sonic dismembrator. With the sonic dismembrator, you will be able to use sound waves to disrupt the cell and to be able to get whatever is inside. So right now what we are going to do is like we're going to take our liquid, these are the cells that are intact, and then we are going to use the sound waves to break them open. I am going to use a power of 35 watts. As you can see, we apply different pulses so we can break the cells open. As you will see, some foam is going to be developing in the process, and this is an indicator that the surfactants that are in the cell membrane are being released. And we need to keep doing this until we make sure that the content of the cells is released. Why do you do that? Because depending on the chemical that you are going to extract, you need to use a different process. If you want to do biofuels, after you lyse the cells open, you need to combine them with solvents or maybe use a column to be able to separate the biofuel that you want. So after the sonication or the treatment with the sound waves, these are our samples. So this one is the sample of algae before the sonication, and this is the sample of algae after the sonication. So these cells are not open, these cells are. So now what we have to do is to be able to separate the biomass from the liquid. And the way we do that is by placing these in a centrifuge. The centrifuge is going to utilize the differences in density of the components of these mixtures to bring the solids to the bottom and leave the liquids on top. So now we are going to put this in our centrifuge and we are going to set it for 10 minutes at 18,000 gravities.
Now for 10 minutes.
So after the time is over, you can see that now the pellet with biomass is in the bottom, and then here we have the liquid. This is the sample that wasn't being created with the sonication waves, the sonic waves, and this is the one after the sonication. So as you can see, we have some biomass in the bottom and we have this colorful liquid. This is an indicator that we have broken the cells, we have sliced them open, and this liquid has some of the cellular contents that were released during the sonication process. Now, if you want to obtain biofuels from these, you need to properly select the liquid that you need to use to continue with the extraction. Depending on what you want, you use a different chemical. So, for example, if you were to produce or to obtain a biofuel, you will need to separate this liquid and work with the biomass, with the pellet. And then you would add a solvent to the pellet to be able to extract the fatty acid or the biofuel that you want. If you wanted to extract a hydrophilic chemical, you will need to work with this colorful liquid. And again, you will need to select a proper solvent and use a separation technique, like for example a chromatography operation. For my research, I have been working on optimizing a process to extract this blue pigment. This is not a biofuel per se, but is a derivative of the biofuel that you can obtain from these cells. So I have been trying to optimize the production of this blue pigment that is useful for the production of cosmetics and medicines. So as you can see, these systems can help us combine operations of biofuel production and high value chemical productions that can be used in different industries.
Thank you, Daniel.
Okay. So after the treatment with the sound waves or the sonication tip, we have our samples. So this one is before the treatment with sonic waves, and this one is before. So you